All right, hi guys. This is another review for you. If you want to try this, I'm going to go through all the answers right here. But this is chapter 10 of your textbook. I never had you do these questions, but they're worthwhile. If you want to practice for tomorrow, this would be something to do. Okay. So chapter 10 in your textbook, do all the questions in this chapter. They're all related to groundwater, so porosity, permeability, capillary action, the zone of saturation and aeration and all that stuff. So I'm going to go through all these questions. If you want to do it first, pause the video here and then go back and check your answers when you're all done. If you want, that would be the best way to do it, I would say. Okay. So it says for number one, the water table usually rises when there is a what? So we're having water. I'm going to draw a picture here, right? We have the surface here. So, there's a tree as best as I can draw it. Okay. Water is going down into the ground and it percolates through the groundwater, infiltrates down into the groundwater and then, or down under the ground. And then we fill up this area underneath here, this is called the water table. And all the area underneath of that is all saturated. So we want this water table to rise. We want more water to be in the ground, the water table going up. So how would we do that? Well, we would need some way to get water into the ground. And if we have more rain, like up here, then more water is going to go in the ground. So if you look through all the choices, what would make more water in the ground? The best answer is number 3, increase in the amount of precipitation. Okay, more rain means more water in the ground. All these other ones actually decrease the amount of water in the ground. They have more runoff going over the surface. Okay. Number 2, by which process do plants add water vapor to the atmosphere? That's a water cycle question. Remember, I always remember trees or plants. Trees equal transpiration. So the answer is number 2. Okay. Number 3, let's see here. Get rid of everything else. Number 3, water was poured into the container under a clay flower pot. The water level in the bottom container dropped to level A as the wet part of the clay pot moved upward to B. Water level B is higher than the water at A because water what? Well, why would water travel upward, like up against gravity? We talked about that like before break. The answer is capillary action, okay? And it's moving up to a higher height because of capillary action. Remember, the water is a polar molecule. It's sticky. It wants to stick to the surfaces of the soil in the container. And the smaller the gaps between the soil, the easier it is to climb up against that. So capillary action is the answer here, and it's going upward. So that's number 3. Okay. All right. Number 4. I got to wipe this slate clean every time. Number 4, which sediment size would allow water to flow through at the fastest rate? So we want water to go into the ground really quickly. That means we want big gaps in between the sediment. And the biggest gaps in between the sediment would be located in the biggest sediment. So the answer is pebbles for number 4. Okay. All right. Number 5. Wiping the slate clean again. Why is much of Earth's water unfit for use by humans? Remember, the use by humans is going to be like fresh water easily accessed. So if you look through the choices for number 5, the fact that most of the water on Earth's surface is in the oceans is kind of the answer to this question. So the answer for number 5 is 2. Okay, so number 2. All right. Number 6. How deep must a well be dug to yield a constant supply of fresh water? Good idea to draw a picture here. So here's the surface. And we have water below the ground. This is the water table. I probably should have made that surface a little differently. Let me erase this. Okay. So make the surface green. All right. So water is going down into the ground. And as it goes down into the ground, it fills up this area underneath the saturated zone. This is the unsaturated zone. How far down do we have to dig a well? So our well has to go down all the way down to water, and it's got to go below the water table in order to access that water. And so this well is dug all the way down below the water table. And so the answer to this question is number 3. Okay. If the well didn't go down below the water table, then it's going to be sucking up air. It's not going to do anything. Okay? All right. Number 7. Number 7, during a heavy rainstorm, runoff is most likely to occur if the surface of the soil is what? So we want the surface to be completely like impenetrable. We don't want water to go into the ground. We just want it to run over the surface. And so if we have something that's going to prevent infiltration, something that's not permeable, that's going to make runoff happen. And if you look through the choices, the thing that's most impermeable, like a rain jacket, is number 1, firmly packed clay-sized particles. Because clay-sized particles are really, really tiny. They don't let water go in. It's almost like bedrock. It stops the water. Okay. Number 8, which soil type has the slowest permeability rate and is most likely to cause flooding? It's exactly the same question as number 7. It's impenetrable, doesn't let water go in. So that answer is clay-sized sediment. Again, number 1. Okay. Number 9. Number 9, we're going to have to flip through this. I'm going to clear the screen here. Tubes A and B, blah, 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 blah. You can read through all this stuff. What I like to do is let's go to the actual question, and then if we have to reference back to that, we will do so. Okay? It says, if the same experiment was performed with tube B, which data table below best represents the expected result? So let's just compare these two. This has big sediment. This has small sediment. This has probably, well, if you look at the data, it looks like it takes very little time for, well, it tells you what tube B is all about. We want to know what, or tube A is all about. We want to know what tube B is doing. Think about water. If water went through here, it'd get through a lot easier than it would in A because these gaps are really tiny. One thing that is the same, the packing, the shape, that means the porosity is the same. Okay? So if we were to like compare the pore spaces, water required to fill pore spaces, it would be identical in both tube A and B. So that's kind of a hint. We were looking for the porosity, that's first box, to be the same. Okay, so that's one thing to take note of, and that means it's got to be either 1 or 3 here. Now, you would expect water to go through the tube B a lot faster because the gaps are bigger, and therefore we would have less time to drain, and therefore the answer is number 1 for this question. Okay, so that takes a little bit of thought there. You have to kind of go through each thing. The permeability of tube B is higher, but the porosity is the same. Okay? Okay. Let's go down here. Number 10. These are good questions right here. This is about the water cycle. I'm going to erase the screen. Which 2 letters represent processes in the water cycle that usually cause a lowering of the water table? So the water table is going down. It's like drying up. So we want water to be going out of the ground. And the best way to get water out of the ground, well, here's a process that's taking water out. That's called evaporation from a lake, right? So that's one process, taking water up out of the ground into the air. Here's another one, taking water out of the ground, transpiration. The roots suck the water up, and then it goes up into the air. That's transpiration. So guess what? It's A and B. There you go. 10 is 1. Okay? All right. Let's see here. Number 11. Clear the screen. What are 2 water cycle processes not represented by arrows in this diagram? So we could go through all the choices. Number 1, transpiration and condensation. No, that's definitely there. Evaporation and melting. I see evaporation. And is there any melting? Perhaps, maybe. It doesn't really show it, but definitely evaporation. Precipitation and freezing. Yeah, we got precipitation. Freezing, maybe. It doesn't show it directly, but runoff and infiltration. I see no arrows going over the surface. Do I have any arrows going into the ground? No. So both of those are not shown. So the best answer is actually number 4 for 11. Okay. Be careful with that one because a couple of these aren't shown, but one of them is. So you got to pick the choice that has both, right? What are 2 water cycle processes? So runoff and infiltration. All right. Short answer. What change in state is represented by D, and how does this change affect the temperature of the air? Okay, well, this is condensation, represented by D. We haven't learned about the change in the temperature of the air when this happens. We'll talk about that later on. You guys don't need to know that yet because we're going to be talking about clouds with meteorology. So ignore the rest of that question. Condensation is really the answer here. Okay. Which of the following events will upset people who use well water in their homes? Well, a park is not going to help. I mean, that's going to help. That's nice. A good thing. Okay, it's not going to upset people. Constructing a gas station. Okay, so now we're burying a gas tank underground. You might recall that I did that interview with my wife about the gas that leaked into the water right underground. So that's not a good thing. So I would probably say number 2 is the best answer there. That's going to upset people. Okay. 14. In which column would capillary action cause the water from the beaker to rise the highest? Capillary action is best in small sediment, so it rises easiest in column D. So the answer is number 4. Number 15, another water cycle diagram here. Describe the process of evaporation. Evaporation is the process by which water changes from liquid to a gas, and it does that below the boiling point, so at a lower temperature. So again, liquid to gas into the atmosphere. Lakes, oceans. Oceans do it best because there's so much water in the ocean. 17, state one land surface condition that would allow runoff to occur. Runoff is going to happen if the ground is impenetrable. So you want the ground to be, non-permeable, really, really tiny sediment like clay. That would help. If the ground's completely saturated with water, then water can't go into the ground. It's going to run off. So saturated ground. If the land is steep, it runs off a lot better than flat land. So there's a couple options there. A lot of options really. 18. Explain one role of plants in the water cycle. Plants take up water from the ground and put it into the atmosphere through the process of transpiration. They also allow water to infiltrate into the ground. So, a couple of roles there. 19. We have a diagram of a well. The diagram below is a profile view of a working water well. If the owner stopped using the well for many weeks, the position of the water table would probably change. On a sketch or a copy of this diagram, draw a dotted line to show the most likely new water level along the periods with no withdrawal of the ground. I'm never going to have you do a question like this, but what would happen is if it's not being used anymore, here's the zone of aeration, zone of saturation. This is the water table. It gets sucked down to where the well line is. If they're not using it anymore, guess what? This is just going to level out, and the water table will just go across like that. Okay. It might dip a little bit, but it's not going to go all the way down to the bottom here. Never going to ask that question. 20. By what process do plants affect the moisture content of the atmosphere? That's called transpiration. Remember, putting the water into the atmosphere. So transpiration for number 20. Okay, so that's pretty much it. Again, if you did those and you did pretty well on them, you're going to do just fine tomorrow. There are going to be some questions about oceans. There are a few questions in chapter 11 about oceans, but I gave you some practice from your workbook for that as well. So you guys should be fine. If you have any questions, just let me know. But hopefully that helped you. Okay, thanks.